Welcome to AI for Good, the leading action-oriented global and inclusive United Nations platform on AI. Organized by ITU in partnership with 40 UN sister organizations and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end, as we will hold a 30-minute networking session in the neural network. Here you can meet, ask questions to our distinguished speakers, connect, and chat with the AI for Good community. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez-Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on weeding and harvesting robots for sustainable and affordable horticulture, jointly organized by the ITU and the Food and Agriculture Organization. This session is part of the AI for Good programming track, where we discuss the role of AI-powered robots in achieving the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our first speaker today. His name is Dr. Jingchua Cha, and he's the Director of the Plant Production and Protection Division at FAO. Dr. Cha, thank you very much, and the floor is all yours.
Thank you very much, dear Chair. Distinguished guests, participants, ladies and gentlemen, good morning, good afternoon, and good evening. I'm very pleased to welcome all of you to this webinar on themes weeding and harvesting robots for sustainable and affordable horticulture. This webinar is joint organized by International Telecommunication Unit, ITU, with the Technical Assistant of Food and Agriculture Organization of the UN, FAO. The webinar will present the efforts to defeat hunger and poverty through transforming agri-food system benefiting from digital agriculture and innovative agriculture mechanization technology. The webinar will also highlight how agro-robotics can help achieve the UN SDG, especially SDG 1, no poverty, SDG 2, zero hunger, SDG 3, good health and well-being, SDG 8, decent work, and SDG 13, climate action. Today's panelists will demonstrate the opportunity and the challenge and consider the issue of inclusivity from perspectiveness of private sector industry, academia, United Organization, including FAO. As you know, starting from this year, FAO is implementing its strategic framework 2022 to 31 to support the transformation to a more efficient, inclusive, resilient, and sustainable agri-food system for better production, better nutrition, a better environment, and a better life leave no one behind. In this strategic framework, better production is fundamental to achieving the better nutrition, a better environment, and a better life. Better production can be achieved greatly through better soil, better seeds, better fertilizer, better pesticides. Of course, with strong support of better agriculture tool, better equipment, and better machine. In line with this FAO strategic framework, let me brief you how the Plant Production and Protection Division NSP is committed to contributing to sustainable crop production system. Our mission is to enable transfer to more efficient, inclusive, resilient, and sustainable plant production and protection through optimization and minimization. Our strategic objectives are ensure food security and nutrition security while enhancing food quality and safety, protecting environments and biodiversity, and facilitating safe trade and economic growth. Our core activity covers sustainable seed system management, sustainable plant production system management, sustainable plant pest management, sustainable pesticide management, sustainable technology promotion and support, here including precision agriculture and agro-robotic. Today, the agriculture sector experiences a new era of development thanks to the integration of technology such as digitalization, mechanization, and artificial intelligence, AI. The AI and evolving agriculture robotic have the potential to revolutionize the farmers' operations to increase efficiency, reduce drudgery, and create new and decent jobs for women and the youth. However, for this innovation to benefit the smallholder farmer, the strong support is requested for various stakeholders, including public and private sector, development agency, academia, research institutes, and civil society. Demonstration in farmers' field is badly needed for agriculture machinery innovation to ensure inclusivity and supported by a fully functioning information technology infrastructure. Today's webinar will definitely provide a space for specialists to discuss the opportunity for strengthening sustainable agricultural mechanization efforts through artificial intelligence, agro-robotics, and innovation. I'm very pleased that this webinar draws on experience of a highly distinguished panel representing private sector, academia, and FAO, continues our collaboration in context of AI for a good initiative. I'm looking forward to further partnership with the International Telecommunication Unit and the FAO. With this few remarks, I wish you all very successful and fruitful webinar. I thank you all. Over to you, Chair.
Hey, thanks a lot, Dr. Shah, for this very impressive opening remarks on the tremendous potential for intelligent precision agriculture technologies and the use of robotics in digital agriculture, and for bringing this topic also in the context of achieving the Sustainable Development Goals for which we are all working for in the UN and in the private sector as well. So thanks again for being with us today. And dear participants, dear everybody around the world, my name is Joseph Kienzle. I'm leading the Sustainable Mechanization Task Team here at the Plant Production and Protection Division of the FAO, Rome. I will be your moderator today in this webinar on artificial intelligence, AI for good, webinar on weeding and harvesting robots for sustainable and affordable horticulture, which is jointly organized by the FAO and the Telecommunications Unit, as you know. We have today 3 distinguished speakers in our panel. Unfortunately, Jakub Namal from Toto Tractors had to decline in the last minute for personal reasons, but nevertheless, let us begin right away with the webinar. And I want to come to the first speaker right away, Mr. Florian Richter. He is the CEO and co-founder of Muddy Machines. He is from a farm and comes to Lower Saxony in Germany, which is the main asparagus region. And that is probably why he has gone into robotics for harvesting asparagus. But let's hear from him directly what's happening with Muddy Machines. Florian, the floor is yours.
Very good. Thank you so much for having me, Joseph. Took me a while to find my unmute button. Thank you to the FAO for organizing this event in the ITU. We have used the FAO online data on crop production, etc., extensively during our market research for the startup. I'll take the next 10 minutes to talk briefly about Muddy Machines, what we do as a company, where we've come from, where we're going, talk about the crops that we're focusing on, and then show, hopefully, technology allows us to a 2.5-minute video of our 2021 field trials, take an outlook over 2022, talk a bit about sustainability and what other things we could be doing to contribute to that. So let's get going. Now, Muddy Machines is the brainchild of 2 founders. My co-founder, Chris, is a ex-Dyson robotics engineer, has built various robots over the course of his career. And like Joseph alluded to, I have more of a business background. I do come from Lower Saxony in Germany, but this has very little to do with where I am right now. Although one day I hope to go back to Lower Saxony and do some asparagus harvesting there. At Muddy Machines, our vision is to sort out and fix the massive labor shortage problems that are currently plaguing horticulture, specifically the subsector of selectively harvested field vegetables. These growers have 30 to 60% labor cost in their cost of production. And because they are not able to get enough workers, in 2020, we've seen a 30% shortfall. Now, with everything that has happened, especially in the UK with Brexit and with COVID, we're now looking at an even 50% shortfall. And this is hundreds of millions of pounds in losses for the growers every year. Some crops that are perennial, you can't even switch from one year to the other to grow something different. Why are these crops so labor intensive? I mean, the name gives it away. It's selectively harvested, so you can't go in with a big combine harvester and get everything out at once. You have to, sometimes even on a daily basis, go in and select plant by plant, fruit by fruit, which one is the one that I can take now, which ones do I need to leave in the field for a little longer. And despite, because of Brexit in the UK, we want to become more independent, more self-reliant, more resilient. This labor shortage is putting this entire horticultural sector at risk. We are likely to soon no longer be able to grow plants like certain brassicas types, asparagus, certain fruits, and so on. And what are we going to do in the short term? We're going to import these, causing a lot of food miles, which is, and again, directly translated into tens of millions of tons of CO2 that we are producing because we're not growing our own food. And that's why I think this is more than reason enough, saving an industry, reducing the carbon footprint that we have in our food system. That is the reason that we believe selective harvesting must be automated. The UK, as in so many things, is a bit of a front runner in this trend. But if you speak to other countries that are strong in horticulture, you see a similar trend applied for, albeit for different reasons, but labor shortage is a problem not only in the developed world, but also in the developing countries. Now, when you look at a food production system, at a farming system that relies heavily on labor, this is kind of the picture that you see. You see lots of people walking over the field, supported by some kind of a tool carrier or even a mobile packing station. And we strongly believe that in order to replace this with technology, or in order to fill the shortfall of labor that we currently see with technology, we need to not develop a big combine harvester that puts tons and tons of soil compacting pressure onto the ground, is very expensive and a massive single point of failure. We strongly believe in our vision of a herd of robots that is lightweight, that is battery powered, and that can be used for a multitude of different types of crops. So it's not the kind of machine that you buy, use for a couple of weeks, put in the shed, and it stays there for the rest of the year. This is a workhorse that we want to be used as many months of the year as possible, because something is always in season. You know, we are now starting, and I'll come to this in a second, to the green bit here, the early growth of green asparagus in the beginning of the year. But there are so many other crops that come into production in the rest of the year, and others that are growing even earlier, that again rely very heavily on a harvesting method that requires a lot of hand-eye coordination, or in the context of this webinar, AI, machine learning, and a precise robotic end effector. So why have we picked a relatively small crop such as asparagus? Well, when you look at this from a robotics point of view, you see quite a lot of things that are advantageous as opposed to other crops that you might have heard of that robotics companies are tackling, such as tomatoes, strawberries, or other types of berries. The premise is usually it's a very big market, strawberries, and how hard can it be to pick something that is red on a green canopy? Well, it's actually quite hard if that thing starts moving as you move your end effector into it. It's quite hard to see under and through any kind of leaves that might be obstructing your view. And with green asparagus, which I understand not many people are familiar with that type of crop, but you are usually not dealing with a very heavy weed coverage. The soil is usually quite clean. They grow up straight. If they're not straight, they are usually not sellable, so you need to sort them out. But the biggest problem is actually how close are they together, and how can you avoid the other spear while harvesting the other one. But as long as you can measure the height reliably, you can select effectively. Now, let me show you a video that we have shot with the largest British asparagus producer of Cobry Farm. Yeah, maybe Joseph, you can intervene if the video quality is too bad, but I'll just roll it now.
Okay.
How hard is it for farmers at the moment to find workers? It is really, really difficult. A shortage of pickers on farms for record amounts go to waste. To find a robotic tool to cut asparagus, the technology is there.
This isn't about saving money on labour. We can afford the cost of the labour, but we can't get it.
We're Chris and Florian. For the past year, we've been working on a field robot that can harvest green asparagus. Countries like the UK need new technology to become resilient against labour supply shortages and have a secure and sustainable domestic food production system.
We needed to design a workable solution whilst not having access to the asparagus fields because the season's only 12 weeks long. So we built our own and 3D printed some. After several feedback loops with John and getting through adverse weather conditions and COVID lockdowns, we finally got there. We've got a working machine.
And we call it Sprout.
I cannot believe that they've made so much progress in 1 year. They've worked away in my fields, and we've actually got a machine that takes itself up and down the rows of asparagus and harvests the asparagus and puts it in a tray.
We've seen some rapid growth in the last year. We've won an Innovate UK grant together with Cobry Farms to develop our asparagus prototype further. We've done a funding round and managed to hire some really smart engineers. We've won another grant, we won pitch battles, we got invited to accelerator programs, and we are now getting slots at speaking events over the wider industry.
And now we're working on the next generation of sprout. It's battery powered, enabling a green future for agriculture. It's lightweight, which means it doesn't damage the soil as it drives over it. It uses deep learning to detect the crop. It drives itself, avoiding obstacles as it goes. Our patent pending harvester cuts consistently and precisely to the grower's specifications.
Join us to revolutionize the future of agriculture, build some really cool stuff, and make a big difference to farmers.
Very good. I'm glad that this worked. Now, just 2 or 3 slides left, and then I'll hand over. So as you've seen in the video, we have in 2022 built Sprout Mark 1. We have now dramatically upgraded the drivetrain and the picker to now have pick speeds that are close to or faster than what humans are picking at. This is already designed with a higher ground clearance so that we can get into other types of crops as well. We're looking at tender stem broccoli, we're looking at courgettes. And it's really quite remarkable how the tool set that is implemented on the robot can be swapped out within a matter of minutes. It's a 2-man job, but you could be harvesting asparagus in the morning and then swap out for a different tool and do some other harvesting in the afternoon. Now, I've alluded to this a few times already during my presentation. I mean, what development goals are we addressing? By dramatically reducing the amount of air freight, by enabling domestic production, by reducing in the long term the need for migrant workers to come into the UK, we reduce air travel, and by using potentially even sustainably sourced electricity on farm, we are contributing to the goal of responsible consumption and production. And by ensuring that domestic production will continue, we'll also address the zero hunger and sustainable food production goal. And I think the carbon emission reductions, that kind of speaks for itself in terms of climate action, and also by extension life on land, because what can you do when you have a working field robot? Well, first of all, of course, you can expand into other crop types, like I've mentioned, but you can also do very interesting things with very simple and low touch mechanical weeding, because you are in the field for 12, 16, 20 hours a day. And while you're harvesting, of course, you can do some very light touch hoe weeding or plucking. And the thing that we are only beginning to understand now is the value of data. When you are harvesting crop, you need to generate quite a lot of image data on the crop and analyze that in order to decide, well, can I pick it? Should I trim it? Or should I just let it grow? And playing back that data to growers might potentially have also some quite significant cost savings in chemical applications, and increases in yields. Good, that's me. Joseph, thank you for the time slot. Next step for me is to go on mute and turn off my video, right?
Yeah, thanks a lot, Florian. This was impressive. I'm sure the audience might have some questions, so we will do the presentations first, and then we have question and answer session. So please note down your question to Florian. That you get a chance later to answer that. It was truly inspiring. I also see that labor, the amount of labor shortage that's really there, at least in UK, which is often it's the opposite. We think it's the opposite, but it's obviously under the specific conditions of Brexit and COVID, it had obviously that effect. So without further ado, I want to go to the second guest, which is from the Nayo company, which is a leading producer of commercially sold weeding robots. We have today Ingrid Sarlandi. She is the Chief Operations Officer at Nayo Technologies. She's passionate about entrepreneurship towards sustainability. She is the chief operating officer of the company. And she told me she decided to join the Nanotechnologies company because she was convinced that bringing autonomy and accuracy to any farmers in the world is a solution to have a global, secure and sustainable food production system. So that's definitely a good reason. And Ingrid, with this small introduction, I think I hand over to you for your presentation.
Thank you so much for the kind introduction. So my name is Ingrid. I'm the CEO of Nanotechnologies. We are the leader when it comes to autonomous ag robots. But first, I just want to pause for a second and recognize all the challenges growers are facing today. And Florian has touched base on a few of them, but it's really important to emphasize the different challenges growers are facing today. First, there's definitely a significant labor shortage and increasing costs of the labor force today, which reduces the thin margin growers have today even more. The population is definitely increasing, and we need to develop a more secure food production system. And last but definitely not least, there's an increasing regulatory pressure to ban the use of pesticides and herbicides and protect our soils and ecosystems. But we need to provide the solutions to growers to be able to have a more sustainable farming production system. And our mission at Nanotechnology is definitely to promote a more sustainable agriculture. We focus on UN SDG number 2, which is end hunger, achieve food security, and improve nutrition and promote sustainable agriculture. And at the same time, we really tackle for additional goals, which is life on land, good health and well-being for our farmers, having a strong climate action, and developing a solution that is responsible in terms of production and consumption. And I'll touch base on this a little later in this presentation. So that's our mission, really to promote a sustainable and profitable agriculture for our growers. And the way we do it is we've developed our own autonomous navigation software. And we've implemented this autonomous navigation software into our range of robots. So we collect data through sensors, camera, our RTK GPS solution, and we feed our AI model. And then our robots can run fully autonomous, fully electric into the field to do multiple agricultural tasks, seeding, planting, weeding, thinning, you name it. And at the same time, collect data. Florian emphasized earlier today about the importance to collect real-time data and provide this feedback to growers. Our robots can do both. So do the mechanical weeding and collect data and provide real-time feedback to growers. This is our range of robots. You can see on the left side are ours, which is our smallest unit dedicated to nurseries, horticulture, professional vegetable gardeners. The video which is playing is our Dino one, dedicated to large-scale vegetables, so tomato, potato, leafy greens, carrots, leeks, you name it, all these large-scale vegetables. And we have TED dedicated to wine growers. As of today, we've already deployed 280 units worldwide. It's the same navigation software on all our robots, so we've already collected a large amount of data. Let me just show you quickly our different range of robots. So you can see the horse playing into some fields, can do some weeding, seeding, making furrows, mowing, planting, and we're really adding more and more services to each robot, because that's what growers want. They don't want just one robot doing one task. They don't want robots to be sitting in the shade. They want the robots to be utilized every single day and doing multiple tasks. And that's why we can provide versatility of services for growers. This is our TED robots. so dedicated to vineyards. Again, wine growers are dying to find more sustainable solutions. They don't have any at the moment. That's really allowing them to have a sustainable farming practices. And they've used a lot of herbicides and pesticides in the past, and they're really looking for new solutions that they can implement easily into their vineyards. All our robots are fully electric, adding an extra value. And because they're running fully electric, in terms of weight, they're very lightweighted. So it has a very positive impact in terms of soil compactions. And in terms of operating, for example, after a rainy day, we can go back to the field the day after a rainy day, which a conventional tractor can't. In terms of our go-to-market strategy, it's based on two main pillars. We sell our robots through a network of dealers, and we also offer as a service business model. What does it mean? It means growers can call us, let us know they have like 200 acres of carrots to be weeded the next week, and we'll come with our robots, our operator, and provide the service. It's a fantastic market penetration tool. It really helps us convince growers, the early adopters ones. And it means, again, faster return on investment for growers and bringing them the solution they're looking for. In terms of the competitive field, we're really providing a highest efficiency with a higher positive environmental impact by bringing these ag robots as a service to growers. Other ways of doing the mechanical weeding or the seeding can be in crew, but there's this labor shortage, the use of chemicals, and we're really trying to reduce the use of herbicides and pesticides and more traditional ways such as tractor and cultivators. But in terms of efficiency, it provides not as good results. It's been a long journey. It hasn't been easy to be able to be where we are at today. The company was created by Emeric and Gaëtan in France. That's where our headquarters is, and now we have operation on 4 different continents. We're a team of 80 people, very skilled people, passionate about sustainability and bringing effective solutions to growers. We really believe that tech is the solution to provide a sustainable agriculture with like 4 main UN SDG we are tackling. We need to have a more sustainable way of managing our arable lands. So it comes to reducing the use of herbicides and pesticides, less soil compaction, limiting the erosion of the soil. That's really what we want to do. The way we build our machines are really in a way to limit the carbon impact. And we're really trying to, in terms of designing our robots, in terms of second life, to have the better impact on the environment. We're really focused on the health of our growers in terms of course, reducing the use of herbicides and pesticides, but also in terms of operating in the fields. Sending an crew to do end weeding is very painful for our growers, and that's something we want to limit. And we're in the process to oversee all this initiative and ready to oversee our environmental mission to get the B Corp certification at the moment, and it should be a done deal by the end of the year. Just as a conclusion, so we really think like ag robotics is the solution for sustainable farming. We've already deployed 300 robots worldwide, logging over 60,000 hours of operation. We've built the most reliable AI solution on the market, and we really want to improve again and again our robots, adding more and more services to growers and being able to address even a larger versatility of crops. We're very strong on the sustainability aspects, and I hope we can bring more advanced solutions to growers again and again. Thank you for your time, and I'm really looking forward to answer any question you might have after this session. Maybe just to end up on a very interesting note, there's a FIRA, which is a big ag conference, is coming to the US. It was first launched in Europe a couple of years ago, and we're having the first ag session with a strong focus on harvesting and robotics in agriculture in October in Fresno, California. So feel free to send me an email if you want to join the session. We'll be an active participant, and I think it's going to be a great event for sustainability in agriculture. Thank you for your time.
Thank you very much, Ingrid, for this presentation, and also that you made it through. I think you have a little bit of rough voice. Sorry for that. And thank you for internalizing the SDGs, and also back to Florian for doing the same. I think it's really very useful to see that innovations in the private sector can are fully aware of what they can contribute to in the context of the SDGs as well, which is not always perceived that way. So thanks, and I please the audience, if you have questions that came to your mind while listening, write them in the question and answers, or even in the chat of your screen, and so that we can reach them and that we can have the data for the question and answer session. So after two speakers, both from private sector, the first one more on the beginning of the scale, while now you're in the full commercial operational scale already. We now would like to come to the third speaker, which is I'm very pleased to have Elizabeth Sklar. She is from academia. She's a professor for agri-robots and research director at the Lincoln Institute of Agri-Food Technology. She is also a visiting professor of robotics in the Department of Engineering at the King's College in London. And she has held previous academic posts at the University of Liverpool, at the City University of New York, and Columbia University. Her research investigates the implementation of artificial intelligence-based methods applied to multi-robot teams, human-machine teaming, and data-backed decision-making and behavior mining. This sounds very exciting. And so maybe we get some little bit more insight from the research point of view, where we are with artificial intelligence and robotics maybe in the context of agriculture. Okay, thank you, Elizabeth. The floor is yours. Please, I'm excited.
Great, thank you, Joseph. I just share my screen here. I have some slides to present. Can you see? You see that okay? Can you see my screen okay now?
It's fine, yeah.
Yes, okay, thank you. Thank you for that introduction. My name is Elizabeth Sklar. I'm a professor in agri-robotics, as Joseph mentioned. I'm based at the University of Lincoln, which is a university located about 2 hours north of London in England. And I'm research director at something called the Lincoln Institute for Agri-Food Technology. Lincoln Institute for Agri-Food Technology, or we call it LIAT, is an interdisciplinary research institute within the University of Lincoln, within the College of Science. And we have several campuses within the university, and LIAT is based on our what's called Rise Home campus. It's a farm campus, 200 hectare farm, where we have a number of arable crops, some horticulture, and a few animals. Most of our research is in arables and horticulture, and not in livestock, although we're starting to look at some aspects of livestock. So here's a few pictures of the campus. I'm going to close with showing you a video that gives you a bit more view of some of the things that are going on. We are a traditional university in the sense that we split our time between research and teaching, although LIAT is more focused on research. We do offer some postgraduate programs in teaching related to the agri-food chain. largely focused on robotics and different ways in which AI and technology can help with agri-food production in a number of ways, both pre-farm gate and post-farm gate, including logistics and those kinds of things. So we do have several PhD programs, we have some MSc programs, master's programs, and we also do professional development. So for in-practice farmers who want to increase their skill set in various ways, we offer what's called basis training and facts training. Most of my presentation today, however, is going to focus on the research side. And we received a large central grant in 2019 from a UK government funding agency called Research England. And that's called Lincoln Agri-Robotics. Lincoln Agri-Robotics focuses on 4 key challenges: selective harvesting, crop care, robotic phenotyping, and carbon and net zero agriculture. The first 3 are ones that we've been working on for a while, and the 4th is something that's emerging. And I'm going to give you a brief overview of the work that we're doing on each of these and tell you a little bit about where aspects of AI come in. So selective harvesting works on developing systems which identify harvest-ready crops to enable reliable and consistent picking. Now, this could be involving robots doing the picking, or it could be involving collaborative human-robot environments where humans, maybe robots do some of the picking and humans do some picking, or maybe robots do transportation of picked produce and humans do all the picking. So it depends on the crop. We do a lot of work in strawberries. We have a small commercial setup with a commercially relevant setup with strawberries, in which you'll see in the video. And so we're employing practical engineering solutions with robotics and AI to do things like compute the yield, which fruits are ready to be harvested, as well as guide robots for doing the actual selection of which fruits to pick and actually picking them. The second area that we focus on is crop care. And again, we're using similar kinds of AI technologies in the sense that you have cameras based on robots, and we're doing some analysis using machine vision and machine learning in order to figure out where are the crops, where are the weeds, where are pests, and different actions can be taken. For example, use of herbicides and pesticides. There's also a rise in using mechanical weeding because of various regulations that have reduced the ability to use different kinds of herbicides and pesticides for environmental as well as economic reasons. So we help support growers in maintaining healthy crops using this precision agriculture technologies. One of the things that we're using AI for, in addition to the vision, is in addition to machine vision and identifying crops, is identifying the location of crops in the field. Yes, you can use GPS, but if you're looking at the, and you can use RTK, but if you're looking at the precise location of an individual plant, often the precision isn't good enough. And so you need to use some AI techniques in order to localize even more precisely the location of individual plants so that you can track the growth. And usually we do this with high value crops like strawberries and other kinds of fruits and vegetables. It's individual plant tracking is less relevant for large arable crops like wheat, where you look more at what's the estimate of the yield for the whole field, and you look for regions in which there may be weeds, but it's less about the individual, because it's very difficult to target one individual wheat ear within a big field. So we have a range of different novel sensing techniques. We're doing some work with commercial UAVs, working in tandem with ground robots. And so that kind of gives you an idea of where we are with crop care. Robotic phenotyping looks at using different kinds of camera and other sensor technologies in order to identify different crops and the growth rates of different crops. And so we're using different techniques to measure how well a plant is performing against its targets, against its predicted growth plan. We're doing a lot of work with wheat in that area and looking at the impact of different kinds of crop care, so different kinds of nutrients being added to the soils and how that impacts the growth of the wheat. So this picture here shows some plot trials that we ran last year where the same wheat was planted, but different treatments were given to different sectors. And the last more emerging area for us is looking at carbon and net zero agriculture. And we now have some specialized data collection devices in our fields, for example, a flex tower for measuring the amount of carbon in the field and looking at different ways in which farmers can adjust how they grow things, for example, using agroforestry to help work on improving the situation for climate change. So some of our newer, more emerging things I mentioned, some of the things we're doing on the net zero agriculture side, looking at regenerative farming, in-field phenotyping, which is the wheat things we're doing. We also have a private 5G network on our farm campus, which we're using to look at how much speed up you get when you use 5G versus say 4G for communication. If you're doing some of this in-field phenotyping and you need to be looking at maybe models that were developed on cloud-based systems, do you need to be able to communicate live between what's in the field and what's in the cloud? Sometimes you do, sometimes you don't. And as a university, we have the sort of luxury to be able to do some scientific research that looks at what are the trade-offs between, say, 5G and Wi-Fi 6, for example, and different ways of making sure that your machine in the field is having robust and continuous communication with other robots in the field and with other humans that may be in the field or working on the farm. I'm going to shift now and give you a quick overview of our activities on a video. And I'll just give a nod to our funders, which are largely from the different UK government agencies, as well as some Horizon 2020 EU funding and some other more private funding. So let me see if I can shift to this one.
(21 to 37% of all the...
Let me start that again.
Agri-food is responsible for 21 to 37% of all the global greenhouse gas emissions. At Lincoln, we're trying to develop a whole new series of technologies to deal with those emissions. We're focusing on developing lightweight robotic vehicles powered by renewable energy instead of fossil fuel, machines which can wander around fields, identify pests and diseases, deal with them in real time without using synthetic pesticides. And we're using AI to help farmers make better decisions, reduce food waste, which will hopefully make a significant contribution to reducing the impact of the agri-food system on our climate.
So I specialize in long-term autonomy. That means making robots move on their own. We're doing this in lots of challenging environments, particularly also outdoors, and we're here at Rice Home, which is our little strawberry farm where we try out these robots. But one of the big problems we're trying to solve here is the problem of food waste. Farmers need very accurate predictions of when the food is ripe, when it should be harvested, and when they want to get it into the market. We can use machine learning techniques, AI, and robotics to make better predictions so that we cut food waste and therefore have a positive impact on the carbon reduction. The big vision here is, of course, that we move towards a fully automated soft food production. That means replacing, in that sense, carbon-intensive workflows that you may have at a farm, all with electrical vehicles that can just operate on their own.
Current ways of producing food rely on wide-scale application of pesticides. This approach, however, is unsustainable due to unprecedented pressures. Our team is working on robotic technology that does not rely on spraying chemicals. Our computer vision systems are able to identify individual weeds, and the robot is able to eradicate individual plants, whilst our navigation system is controlling the robot carrying UV light, which is destroying the powdery mildew in strawberry plants. Currently, we are working on improving that technology so that it can work with any type of disease in different crops and in different fields.
One of the projects we're looking at here is on biofuels, which are an alternative to fossil fuels like gas and coal. And these are just plants that we burn for electricity. We want a lot from these plants, so we don't want them to use a lot of inputs because those inputs themselves take a lot of fossil fuels to produce. And we don't want them to displace food, so we want them to grow on marginal land, and we want them to be very space efficient, so produce a lot of biomass in a small area. A really good candidate species for this is Miscanthus. It's a big tall grass that produces a lot of biomass in a small area, and the project will be looking at how to help that establish and grow more in the UK.
Phenotyping is a technique that analyzes sensor data such as camera images and recognizes traits that characterize individual plants. This is a very difficult task, especially if you're trying to determine actions to be performed in real time. We are developing state-of-the-art machine learning techniques to solve this problem, particularly focusing on methods that will perform quickly and accurately in the field. Limited image analysis can be conducted on a robot in the field. However, we are looking at more sophisticated methods that offload some of that processing to faster, more powerful computers in the cloud in order to perform more accurate image analysis.
One of the things we're doing at the university is looking at carbon monitoring throughout the agricultural system and the arable crop production. It's really important for giving soil some really good, healthy, beneficial properties. It can be a habitat for biodiversity. It can help with flood resilience. And it's also great for crop growth itself and providing a nice environment and soil for roots to exploit. One of the things we don't fully understand yet is the role of different crops in carbon dynamics, in taking up carbon from the atmosphere. So what we're trying to do here is use a flux tower to monitor carbon fluxes from a crop. And as we move into perhaps more novel crops, we're going to get a detailed assessment of the actual carbon budget of those crops.
So thank you very much. That ends my presentation.
Yeah, thanks a lot, Elizabeth, for this interesting presentation and including the short introduction about the research fields, which was definitely also very useful. Let us go to some rounds of question and answer right away for all of you. I have here some questions in front of me, and also they're coming in a few through the chat. Maybe I start with go back to Florian. In your presentation, I heard 1 year as somebody said 1 year. So is that more or less, how long did it really take for you to before, I mean, see that field the first time and then having the robot operating more or less autonomously? Is that a year or is it more than a year?
It depends on when you start the clock, right? It took us to build our first prototype. It took us about 6 months. Was that thing autonomously operating in the field? No, most certainly not. That was more remote controlled and aiming to prove the ability to actually pick crop. The generation for this year is certainly able to, navigate, drive autonomously, follow a path, etc. So I would say, yeah, 1.5 years for that. And I mean, there's an infinite amount of improvements that you can do. I'm sure the guys at NIO have also got some stories to share on how much work it is to get a robot to stop when someone decides to walk in front of it, although they have no business even being in that hectare or these hundreds hectares that the robot is in. I mean, you have advantages that every year more and more libraries become available that you can make use of, and this kind of development is certainly speeding up, right? 5 years ago, this was absolute wizardry, and now it's kind of table stakes for being a robotics company is to solve that problem in some form or another.
Okay, so you have people walking into a robotics field. That's not good of us.
I mean, it is a public right of way in most fields in the UK. On the continent, that looks a bit different, but whether someone is allowed to be there or not is besides the point. If you mustn't run them over. And also there are always workers interacting with, unloading, loading, inspecting the machine. That is something you absolutely have to get right. Although the movement speeds aren't too high, right? It's not anywhere near as complex as cars that are navigating in traffic.
Okay. I guess there's a lot of laws also coming on that point. But let me go to Ingrid now for another question. I mean, we have seen Florian has really focused on one crop. So which crops now you're focusing on, and also maybe in that context, maybe it's also about where is the biggest margin, or where is the biggest value gain? I mean, which crop is your, let's say, your favorite one in order to get machines?
No, that's a fantastic question. Honestly, because of our range of robots, we can address a large amount of different crops. We started by specialty crops, in particular leafy greens, because that's where we could provide the most value. In California, some of the crops are grown on 2x2 beds, even on 10 lines. So you have to imagine beds of 10 lines of lettuce or romaine on acres and acres. But now we can address a lot of different crops. And that's really, if we can do it, we'll do it. We'll adjust, fine-tune the tools, and just try with the growers and see if we can provide a good enough value. And that's the way we like scaling our business. Last month, we addressed tomatoes for the first time, and it was a huge success. And the growers had no other solutions. At beginning of 2020, we did potatoes. I don't know if the audience is familiar how potatoes are being grown, but basically what the grower used to do is burn everything with propane in order to prepare the field. So at the beginning, it would just burn everything with propane, and there would be very limited weed remained in the fields. But with the increasing cost of propane, that's something you cannot afford, not to mention the sustainability part of this practice. So basically, we can do pretty much all of them. It's just about finding the right set of tools and working with the growers to make sure what they want to achieve and do a good enough job. And I saw in the chat, maybe someone has had a specific question regarding the electric consumption, electric power. So our robots are all fully electric. They can run between 8 to 10 hours a day, and then we'll charge them overnight. And with our large scale robots, we can swap the batteries. And that's really what the growers are looking for, being able to run multiple shifts in the day. So you just do 8 to 10 hour shifts and swap the batteries and go for another 8 to 10 hour shifts and go over again. So that's very, in terms of practicability, it's pretty amazing.
Thank you. Let me go to Elizabeth before we go maybe to the audience. Elizabeth, from the academia point of view, I mean, action would be, well, first of all, yeah, I mean, what is the, okay, universities may help, of course, with research, but what I would be more interested in, what is your view on the infrastructure that farms will maybe need for artificial intelligence and robotic solutions? I mean, and maybe also if that infrastructure is there in UK, but maybe what about other countries?
So probably, obviously there needs to be power source, and you need to be able to charge the batteries for robots. I think the biggest, most important, aside from power, I think the most important infrastructure component is around connectivity. So having some, whether it's 5G or 4G or Wi-Fi or some, LoRa, there's a number of different telecommunication mechanisms that are existing. And if you're going to have a robot in the field, as Florian mentioned, in the UK, there's right-of-way public footpaths. And so you have to be able to expect that there may be somebody who knows nothing about robots in the field and may not even be expecting that there's an autonomous robot in the field. And so you have to be able to have good connectivity and robust connectivity without dropping signals to make sure that the robot is able to use the models that have been constructed to recognize what's in the field, and also to be able to communicate to others who are around to say, this is what the situation is, this is where I'm going, this is why I'm stopping, that kind of thing. So maybe I'll just touch on one of the questions in the chat, which is asking about experiences with looking at behavioral barriers, like psychological, social, and economic. There's an interesting question of regulation, and it's something that's being looked at with the use of autonomous cars. If there's an accident, who is responsible? And whether it's the manufacturer or the driver, and you have the same problem with farms. A lot of the financial barriers for farmers to start using robots come down to the initial investment outlay, not only for the infrastructure, because most large farms don't have a telecoms network throughout the whole farm, especially if they're in more rural areas. So a lot of companies, there's a sort of growing industry now of companies that are providing robots as a service, so that the farmer doesn't purchase the robot, but they purchase a service contract to have a robot come and do certain tasks on the farm, which does harken back to some traditional ways of using expensive farming machinery, 100 years ago, kind of thing. So then there's, adds another layer in terms of regulation, who might be responsible. That question doesn't, it's an important question that needs to be solved, but it's, at the moment, it's not the thing that's holding back farmers. I think the biggest thing, at least from my experience, is having the initial investment and understanding the transition from the way they're doing things now to the way they would do things if they had either a fully robotic field work, or if they had some hybrid human robot field work, and understanding how that transition would impact their crop. Because the bottom line is, when it's harvest season, they need to pull in as much yield as they can. And it's a very, farming is a very low margin endeavor. And so you don't have a lot of room for error. And, even though if you can say to farmers, this will help you in a couple of years' time, if it doesn't help them tomorrow, they're usually much more reticent.
Thank you. I mean, this brings me back to this issue of the labor question. I mean, Florian obviously has a case where the farm was desperately looking for the robot, while I wonder if maybe, Ingrid, if you have, I mean, maybe reading is different. I wonder if in your work with NIO, if there is also the opposite, that there is a resistance, or maybe even farmer or farm workers being maybe scared about the robot to come, basically. I mean, how is that situation for a company like NIO? It's obviously replacing manual labor with robotics, the case.
Yeah, no, that's a great topic to address. The thing is, we're not replacing the labor force, because the labor force is not there anymore. If you ask anyone if they would be willing to work 10 hours a day in a field by 100 degrees Fahrenheit, which is like 40 degrees Celsius, they would probably try to find any other job than working in a field, because that's a very painful, very difficult job. And after too many growers, we've saved over the last 3 years in California, many fields, because growers could not find anyone to come do their end weeding doing some seeding. Recruiting some tractor driver is almost impossible right now. And trust me, they're very well paid because to find a gifted tractor driver is very difficult. And the situation is the same in Europe. The situation is the same in the US. The situation is the same in South America. We cannot find people working in the field. In Japan, the average age of birth is 70 years old. Can you believe it? 70 years old. So there's definitely a shortage in labor force. The one that would often oppose is that we might have a negative impact on job the states, the regulators, because they're afraid that we might not have enough skilled people to operate the robots. But that's the reason why we've designed very easy robots to operate, because we don't want the growth to have to hire new labor force, new operator, new skilled people to operate the robots. So they're very easy to handle. They would not require any additional skilled people to join the growth. So definitely not reducing, not cutting jobs, but really providing a solution where the labor force is not available anymore.
I think one of the important things to pick up on, which Ingrid, you hinted at, is that the job market is going to shift. And so the kinds of manual labor that we've seen in fields will be replaced by robots, but that's going to open up opportunities for other kinds of jobs, for people to build robots, to maintain robots, and to operate robots. And so part of the mission for us as a university is looking at what kind of education do we want to provide with students now, so that in 5 years' time, when they're out in the job market, or 4 years or whatever, that they have the skills to pick up the things that these robotic companies are developing.
Yeah, one thing is the next generation of researchers and of farmers. The other thing is the farmers of today, basically. The owner of the asparagus farm is fairly, also at least in his 60s, I guess. And I wonder, is it possible with the farmers of today to make that transition? Go autonomous equipment, and do we really have to wait for the next generation to come, or do we have that time, basically?
So one of the things,
right?
Sorry, go ahead.
Farmers are entrepreneurs, right? And these people have built impressive businesses in order to be in the place that they're at. And it might not seem like it today, but they've certainly always been innovative, whether it was 50, 60 years ago, where they adopted larger machinery or implement the growing practices that are standard today. I don't think we have to wait for a new generation of farmer to adopt new technology. These guys are always looking. Our first farm visit, we were shown acres of test fields where different kind of varieties were being tested. We were shown buggies where people were sitting on and driving over the field, harvesting asparagus between their legs. And the budgets spent on that are eye-watering, and that is not only Cobre Farms. We would have been very pleased to get this kind of annual R&D budget just as our seed funding to begin with. And I think farmers are extremely innovative and extremely open if you have a clear value proposition. If you can say we've listened to you and we are dedicated to solving this particular problem. But if you come and say, I think your problem is the following, here's some piece of technology that you may or may not be interested in, please use it. But that's, any business is going to not engage. This is not specific to farmers, in my view. And maybe to pick on what Ingrid said, in terms of the jobs, fully agree. We're not replacing people. We're kind of filling a gap that exists. And of course, this is hard to convey to workers that are currently active in the field. We also get a lot of skeptical looks by the harvest teams when our robot drives by. But the bigger picture is that these growers, if they don't see a couple of years down the road that their labor shortage issues are solvable with robots, they would exit these crops probably today. And that would cut off any kind of harvest labor operation probably next year already. And so we're actually not replacing jobs, we are enabling the survivability and the viability of these businesses giving those jobs.
Interesting, yeah, definitely. Now I have here some quite specific questions, I think for Ingrid. The first one was, from the audience, have any non-horticultural row crop farmers purchased your horticultural weeding robots? Or, I mean, is this a question to?
Yeah, no, honestly, we love demoing our robots because we just show the robots and just ask the growers what they would do with it. And they just come up with amazing solutions because they know the needs, and they would just fine tune the robot to whatever needs they have. Let me just share a quick story. One of the growers on his nursery, he bought a robot to do some seeding, some mechanical weeding, and he decided to implement a megaphone on top of the robot to scare the birds at night, because the robot is fully electric, fully autonomous. So why just not use it to scare some birds at night? And it's working well, but we've never designed a robot to do such a thing. So you have to imagine our robots as tool carrier, and you can just implement whatever tool you want on it. And our dealers are doing a very solid job helping growers fine-tune our robots with the proper tool. So yes, definitely, it's been used to handle very different crop configurations and services.
That's a great story because it echoes what we've seen in technology development since day one, which is that you put something in the hands of the users and they always come up with ways in which the engineers originally didn't realize how it would be deployed. And the classic example is text messaging, which was not meant to be a feature of a mobile phone, but is one of the most common ways people use mobile phones.
Yes, and then I have another technical question for Florian. Do you use any drone-based imaging technology to decide on the degree of ripeness for harvesting? I mean, is it part of your portfolio, or you do it differently?
No, we don't use that. I think Elizabeth mentioned drone technology has more applications in classic cash crops, where it's not so much a per plant game. In the selectively harvested field vegetables, you can be certain that there is something there to be harvested every day. The question that the growers today face, however, do I deploy a 20 people team into a field where I might only pick like 20% of the maximum or ideal yield I would expect in a day, or do I wait a couple of days until more has come through? But I do then, it's like a bell curve, right? Then on the other side of the bell curve is crop that has then become overripe. In asparagus, they become too large, they start to flower, they start to open up to fern, is the term. But it is inefficient to use drones for that kind of inspection. You can kind of, with experience and a little bit of spot inspection in the field, the growers understand, okay, it was warm yesterday, we should have some good crop today. We harvested that field for the last time 3 days ago. We definitely need to go back in on that day. That is how they work this out. There are drones being used currently in asparagus, for example, to work out patches of suboptimal growth. When the season is over, the asparagus needs to grow into fern. so to recharge the energy of the crowns, or the roots. And you can then, with a drone, after a couple of months of that growth, observe where is strong fern growth and where is weak fern growth. And then you can spot potential issues, you know, some infestations, some deficiencies in the soil, some compaction. We hope with data that we can, by observing or measuring all the spheres that we drive over, that we can show this kind of insight already during the season, and not only after the season once you've had the ferns growing. So that's our take on drones. If anything, what we're doing could make some existing drone applications superfluous. But let's see, it's definitely an important component in you know, surveying your fields, drones as such.
There's some practical limitations with using UAVs. One is around the regulation, so where you're allowed to fly it and how close you can have UAVs next to people in a field. So that's going to limit being able to look closely at objects. The purely practical thing is that so we use not fixed wings UAVs, but different, like quadcopters, that kind of thing. And because it has a rotating part, it's going to blow the leaves of the crop, and it's going to obfuscate the vision if it's too close to the plant itself. So there's a balance there.
Yeah, with a robot you can get as close as 20 centimeters or less, right? That's the last centimeter advantage, as you will. And you have not, you can for a robot, it's very easy to stop or to move very slowly. The advantages of a drone that covers a large area goes away when you're really interested in very, very small areas or aspects of individual crops.
Okay, that's similar to the future kind of. I mean, what is your vision, Florian? What is the next crop? What is the next? I mean, Muddy Machine sounds interesting company name, so a lot of things are possible with that. So are you already working on something else besides Asparagus?
Yes, we're working on a couple of other crops. We've won some grants from Innovate UK, who are a massive enabler and supporter for companies like us here in the UK. There are things in brassicas, there are certain courgettes that all, you know, anything that is harvested by hand today is fair game. There are crops that are currently mechanized but could really benefit from sort of hand harvesting if you only had sufficient labor available. It is something that will take its time. You know, these kind of developments aren't quick. We think we've picked the easiest crop to start. And now, for example, if you wanted to pick a courgette, you know, those things we have currently a end effector that grabs something and then cuts something off with a blade. In courgettes, you shouldn't use blades unless you disinfect them, because you can transmit diseases from plant to plant. So our plan is to introduce additional skills to our end effector or in our end effector portfolio, to then, you know, go from one crop to another. And once two specific skills have been developed, maybe there's a third crop that iteratively benefits from the combination of these two skills. You know, we have to work out, how do we displace leaves so that we can actually see what we are supposed to be harvesting? Can you get around that with the camera, or do you have to actually move the leaves out of the way? Actually blowing on leaves is not something that is too far-fetched, Elizabeth. Some companies are trying that to give it a little push to see what the crop is underneath. Our vision is, I think Ingrid used the word tool carrier, and I think that is what robots needs to be. A robot cannot be a specific one-trick pony. It needs to be able to do more than just one thing, ideally at the same time, but at the very least with a very quick tool swap that the farmer can do themselves. Otherwise, I think as an industry, we already struggle with the budgets or the kind of the unit economics that we have to hit as competing with labor, right? If you're building robots for the defense industry or for the nuclear power maintenance and cleaning industry, the budgets are much bigger, and companies can afford to spend hundreds of thousands of dollars on a single robot. In farming, far from that, right? Even in the first world, a harvest worker costs something like $5,000 to $10,000 for a season. That's it, right? It's not an awful lot of budget you can play with there, and so we always need to focus on what is the labor aspect that we are tackling. How much does that currently cost the farmer? How much better can we potentially do it? But you can't go and say, hey, we have a solution for you. It's going to cost you 3 times as much. That doesn't work.
One of the things we talk to farmers about is that robotic labor can work 24/7. So with human labor, how many theoretically can work 24/7? So, human labor, there, of course, people, need to eat and sleep, etc. So you're not going to get people working overnight. So although we want to be able to say we have a robot that will harvest as fast as a human, if we say, well, this is what a human will achieve in a day, if this, 8 hours of human work versus 20 hours, say, of robot work, we're able to compare numbers that way.
But I mean, we assume that your harvesting robot may be replacing 6, 7, or 8 farm workers. So the budget increases, of course, a little bit. It's not only one that is replaced. On the other hand, my question goes back to Elizabeth about the training opportunities. I mean, does this require a full engineering studies? Or are there short courses for specifically operating the robots, or are the companies doing this? Is NIO specifically having short courses for operation and maintenance, or is this somebody you have to bring from university, a skill?
So I think it depends on what level of activity you want the worker to be able to perform with the robot. So one of the things that's really challenging to me from this domain, from the perspective of being a roboticist, is that every crop is a bit different, and every skill that you need to harvest the crop is a bit different. And so it's very challenging to build a robot that would go from asparagus to broccoli to mushrooms, for example. You need to have different technologies. If you need somebody who will only work on an asparagus robot, they can be trained on the farm. They can be trained by the company providing that robot. If you need somebody who's going to need a broader skill base to be able to move from different crops, different types of robots, then you may need somebody with a full engineering degree. But there are different kinds of courses besides traditional undergraduate and postgraduate degree programs in agricultural engineering and agri-food technology. There are short courses that are offered by different universities. So we offer these professional development courses. And then there are things that the companies who are developing the robots will provide training.
Yeah, I fully agree with Elizabeth. We're definitely providing training to the growers ourselves through our dealer network. Dealer are the ones that are going to train most of the growers. But we're also working very closely with all the universities to make sure these new skills are well trained in the different curriculum, and that the way we're training our next generation do have the requirements it needs to develop and keep improving these robots. And again, the knowledge about the crops really belong to the growers, and we're learning a lot from them. We don't come saying we know everything, because we don't. Every grower likes to grow in a certain way, using certain tools, certain brands, certain equipment. So what's really needed is to spend time with the grower and really understand their practices and what they want to achieve in the future, because some of them definitely want to shift their practices and need our expertise and knowledge, but you need to spend time with the growers.
Okay, we are supposed to wrap up in the next 2 minutes at least. I just got 2 more questions in. I mean, for Ingrid, one specific for you. What is the coverage per day for the Dino? And how many acres you weed per day, but specifically for the Dino? This seems to be somebody who is potential clients, it looks like.
Good. So 1
might give him
Dino
a quick-
per shift, 1 Dino per shift can run up to 10 acres a day. So in terms of hectares, if I'm correct, that's 20 hectares a day. And remember, we can swap the battery. So, and our robots are designed to work in fleets. So there's this magic number that growth for large scale vegetable like to see about 200 acres a week. And that's definitely something we can achieve by leveraging multiple 2 shifts a day and a fleet of robots. So I hope that answers the question, and honestly, feel free just to reach out to me and I'll answer all the detailed questions about our operations.
Then there was a last one on policies. I mean, maybe that's for Elizabeth. Do you have robotics or artificial intelligence policies already in place? And if so, this person would like to be linked to those policies. I guess that's also country specific. I mean, there must be policies in UK and also in France, I'm sure, maybe also in California. Maybe this is a question that's a little bit complex, but maybe
yeah,
it's possible.
I mean, I think probably the best place to look is at the GDPR regulation on data protection. And then the UK is currently using that, but adapting because of Brexit. Yeah, I can put a link to that in the chat, but it's really an emerging area. So
if the question is more about autonomy and what you can do with robots without supervising them, I think there's a 2006 EU directive that's adopted in the UK. I don't know the name of it right now, but the entire industry is waiting for that to be updated because it still is kind of antiquated in the sense that a robot has to be supervised similar to what you have for drones, always line of sight with an operator or someone who can intervene. On private land, it's a little bit easier as opposed to the car companies, but I think the best place to look is in the EU directives for Europe. But as far as I know, also in the US, we're waiting for new legislation to come out to effectively enable what we're all envisioning, right? Robots actually operating autonomously at a larger scale.
Yeah, and NIO is very active in working with both the European regulation and the American one. So if you want more information, happy to connect and provide you the landscape we're trying to build. And what I really like with this industry is all our competitors, all the different players, we're working together to make sure the regulation is shifting towards the right direction. And it's nice to see everyone really cooperating, because if we don't have the regulation on our side, then there's no way robotics can scale. So always happy to share all the different initiatives NIO is part of to make sure we have the correct landscape, regulatory landscape.
Well, thank you, all of you, and also the audience for the questions. We're getting close to 5:30. I think at this point, besides a very big thank you to Elizabeth, Ingrid, and Florian, I wanted to ask if I can introduce Sebastian Bowser. He's our wrap-up speaker. He will introduce, make a quick wrapping up. Thank you for being here, Sebastian, on short notice. Sebastian is the head of the Interactive Cognitive Systems at the Fraunhofer Institute, Heinrich Hertz Institute, the chair of the ITU focus group on artificial intelligence, agriculture. I think he's the right person for this job. And over to you, Sebastian, for your opinion and your into this discussion. Thank you.
Thank you. Sorry. Thank you, Joseph. Thank you to all the speakers. It was a very, very interesting discussion. Very nice webinar. And I'm really glad that you are having me here. I'm really honored by that, by the invitation to give some closing remarks here. So with the vision and the use of autonomous systems in agriculture, robots are obviously a core piece. I mean, they allow to actually manipulate the environment and apply the interventions that are necessary for sustainable and efficient agricultural practices and production processes. This webinar provided us with a very broad and at the same time very detailed insight into current approaches and challenges in agri-robotics, and we had very, very interesting perspectives on that. The use of robotics and of robots in such a heterogeneous ecosystem as agriculture is clearly also relies on interoperability. And therefore, I would like to take the opportunity and draw your attention and invite you to the next upcoming meeting of the ITU FAO focus group on artificial intelligence and Internet of Things in digital agriculture. It will take place virtually on May the 9th and the 10th. And robots obviously have a very special importance there in this focus group as well. There is still the chance to contribute with use cases and providing perspectives, and I would be very, very happy to see you there. I think that these webinars, and especially this one, provide a very good platform to contribute to to advance the field of digital agriculture, to achieve sustainable and efficient agricultural production processes in the near future. So I'm very happy to have heard all these discussions and to see so many people working in the field. Thank you.
Yeah, thanks a lot, Sebastian. With this, I think we are almost at the end of the moderate part of this webinar. I think Gun will come back to us, yes, and to hand over and tell us what's possible with this platform for the next 30 minutes. Thank you.
Thank you so much, Joseph, and a big thanks to all our speakers, Dr. Cha, Florian, Ingrid, Elizabeth, and Sebastian, as well as to all the participants for making it such an interesting discussion. Now, we really encourage you to check out our AI for Good program online to see more robotic sessions that may be of interest to you. For example, on Thursday, the 16th June, we'll be discovering how robots are driving the energy industry transition to a more efficient, safer, and eco-friendly paradigm. And on Thursday, the 30th June, we'll have a session on autonomous robots transforming the future of construction. And we are very much looking forward to welcoming you all on board for these sessions. And now is the end of this section, and it's time for the networking in the neural network with the panelists and the participants for the next 25 minutes. So see you all in a couple of minutes. And now I will give the floor back to Anna for the closing information. Thank you a lot.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the satisfaction survey, connect with interesting profiles, or speak one-on-one using the chat and video function. After the 30-minute networking session, we invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits and poster boards, and build your personalized AI for Good program. It was a pleasure learning with you today. See you at the next AI for Good.